Hello everybody, chapter 6.2 continuation. This is our second example. We will be doing problem 6-5 in your book on page 287. It is asking us to determine the force in each member of the truss and state if the member is in tension or in compression, and we're setting theta, which is this angle here, to 0. Put it in red so you can see it. So if I was to draw my free body diagram of my truss, I have a pin connection here. So I have AX and AY, and then I have, since this is 0, this would be sitting straight down, so we'll call this CY there. So that would be my free body diagram if I took the pin off and my roller off. So I'm just going to kind of cheat and put that free body diagram in there. We're going to need to find excuse me, we are going to need to find, and we'll call this alpha. And so alpha is going to be the arctangent of 1.5 over 2. So alpha is going to be 36.9 degrees. So that's also going to be alpha here as well. So the first thing we're going to do is we are going to find our reaction forces. So I'm going to sum my moment about point A, and I've got negative 4 kilonewtons times 2 meters plus CY times 4 meters minus 3 kilonewtons times 1.5 meters is all equal to 0. Plugging that into my calculator, doing some algebra, 3.125 kilonewtons. Sum my forces in the y direction. I got AY minus 4 kilonewtons plus what we got at CY was 3.125 kilonewtons is equal to 0. So AY is going to be 0.875 kilonewtons. And then if we sum my forces in the x direction is equal to 0. That's x positive, that way my y was there. I say AX plus 3 kilonewtons is equal to 0. So we know that AX is equal to negative 3 kilonewtons, meaning that the actual direction of this is going to the left. So let's do the joint method. I would start at joint C. So joint C. So I draw my free body diagram at joint C, and I have a reaction force of CY, which was 3.125 kilonewtons, and then I have DC, and I have BC, DC and BC, and I drew them both in tension, and again this was alpha. So if I sum my forces in the y direction here, and why do I sum my forces in the y first? Well, if I sum my forces in the x, I'd have two unknowns. If I sum my forces in the y, I don't need to worry about BC, so I'm solving just for DC. So I get that DC times the sine of 36.9 plus 3.125 kilonewtons is all equal to 0. Using my algebra skills, I get 5.2 kilonewtons, which is negative, which means it's in compression. Sum my forces in the x. Now, since DC is actually negative, we're going to be looking at it going in this direction. So when I sum my forces in the x, I am going to say that DC is actually positive. So I change the direction. Or I could do the whole double negative, right? A negative and then negative which would be positive, so it's actually going to be 5.2 kilonewtons. And that's the most difficult thing that students have is grasping that whole tension and compression and which way its direction it's going. And then minus BC is equal to 0. So BC comes out to be 4.16 kilonewtons in tension. So I have those two answers there. The next joint I'm going to do is I'm going to look at joint A. So if I look at joint A, I've got AD, I've got AB, I've got AY, which was 0.875 kilonewtons, and I had AX. Now don't forget that AX was negative, so it is going left at 3 kilonewtons. So remember that direction there. So if I sum my forces in the Y here, is equal to 0. I'm going to get 0.875 kilonewtons, that's positive, plus AD is positive as well. This was also alpha, so times the sine of 36.9 is equal to 0. Again, algebra, I get 1.45 kilonewtons, came out negative, so this is in compression. So I got me another answer there. Okay. Okay, so now I'm going to sum my forces in the x direction. If I sum my forces in the x direction, I get negative 3 kilonewtons plus AB minus 1.45 kilonewtons times the cosine of 36.9 degrees. Is all equal to 0. So we're going to get the AB comes out to be 4.17 kilonewtons, and that's going to be in tension. And then the last one is joint B. So I've got all of these. So I have BC, AB, I got my 4 kilonewtons going down, and then I have DB. Well, I already have BC and I already have AB, so the only thing I'm looking at is DB, and I have it in tension. Well, this is very simple. If I sum my forces in the Y, I get DB is positive, minus 4 kilonewtons is equal to 0, so DB is equal to 4 kilonewtons, and that would be in tension. So what I'm also going to do is I'm also going to upload the sheets that I've done, just the example, and that way you can follow my work as well. Please let me know if you have any questions. I know this can be confusing on the directions, so please let me know if you have any questions. Thank you.